Chemistry, a thing between you and me. Okay, guys, welcome to this lecture series. In this series, we'll be covering everything you need to know about the periodic table, from all the groups to the transition elements. This is in order to help you prepare for your JAMB examinations. But for the purpose of this lecture, we'll be starting with Group 1 elements, and then the next lecture Group 2 elements, and we'll just go from there. So, before I begin, there are basic things we need to know about the periodic table, like groups and periods, for instance. Like, when you hear the word group, what comes into your mind? Okay, so a group is a vertical row of the periodic table. If I go vertically like this, then this is a group. Vertically, this is another group, and it goes on. A period is a horizontal row on the periodic table. So, minus the transition elements, there are 8 groups and 7 periods. But if you were to add the transition elements, you would have 18 groups. So let me just blow out the transition elements. So minus the transition elements for your stage in chemistry, there are 8 groups and 7 periods. 1, 2, 3, 4, 5, 6, 7 periods. Now these 8 groups, they have special names. Group 1 elements are known as the alkali metals. Group 2 elements, the alkaline earth metals. Group 3 elements, boron family. Group 4 elements, carbon family. Group 5 elements, nitrogen family. Group 6 elements, oxygen family. Group 7 elements, halogens, also known as salt formers. We'll find out later on why they are called salt formers. Then group 8 elements, or some might call it group 0 elements, they are known as the noble gases. You also find out why they are called noble gases. It is also important to note that elements belonging to the same group will have the same number of electrons in their outermost shell, but will have different number of shells, while elements belonging to the same period will have different number of electrons on their outermost shell, but the same number of shells. Now, this is really important and will serve as a foundation for a lot of things I'm going to be saying. So let me just move it to the corner for reference purpose. Okay, so now that we have a basic understanding, let's delve into what we have today. Group 1 elements. So, Group 1 elements. So these are the Group 1 elements, and these are their electronic configuration. Now, I hope we remember what electronic configuration is all about. If we don't, it's no worry at all. I'll still cover that in a separate video. So, Group 1 elements, we have hydrogen, lithium, sodium, potassium, rubidium, caesium, and francium. Now, referring back to this thing I highlighted over here, notice that they all have the same number of electrons on the outermost shell. Hydrogen has 1 electron on its outermost shell, and so does lithium and sodium and potassium and rubidium and caesium and francium. Now that we know the number of electrons in their outermost shell, we automatically know their valency. In other words, all Group 1 elements have a valency of 1. Great. Now let's look at the trends down Group 1. The first thing we are going to be considering is the atomic radius. From these images, we can see the number of shells these Group 1 elements have. Hydrogen has 1 shell, and lithium has 2 shells, sodium has 3 shells, potassium has 4 shells, and so on. So notice that the number of shells increases as we go down the group. Perfect. Now, it is important for us to know that there is this affinity between the nucleus and the outermost electron. The nucleus of any atom tends to want to pull the outermost electron towards itself, thereby decreasing the size of that atom. But the force of pull, however, is dependent on how far the outermost electron is from the nucleus. Like in hydrogen, for instance, the force of pull would be greatest because of the proximity of hydrogen's nucleus to its outermost electron. The force of pull would then decrease from lithium to francium. This shows that the atomic size increases down the group. Next is trends in electronegativity. What is electronegativity? It is a measure of the tendency of an atom to attract a bonding pair of electrons. Generally, group 1 elements are known to have a low electronegativity, and this is because in the outermost shell they have just one electron and would rather lose that electron to gain an octet or stable structure than gain an electron as elements such as fluorine, which has 7 electrons on its outermost shell. Fluorine, by the way, has a high electronegativity, but we'll save that discussion for when we talk about halogens. Okay, so now we know that group 1 elements have low electronegativity. But the question is, amidst group 1 elements, which of them has the highest electronegativity? The rule is electronegativity would decrease down the group, that is, from lithium to francium. Up next, trends in electropositivity. Group 1 elements are electropositive elements because they have the tendency to donate electrons and form positively charged cations. This trend occurs because as you move down the group, the atomic size increases and the pull of the outermost electrons on the nucleus decreases. This makes it easier for the outermost electron to be lost, thereby leading to a greater electropositive character. Next, ionization energy. What is ionization energy? This is the energy needed for the removal of the valence electron, that is the electron on the outermost shell of an atom. Now, this trend decreases down the group because with increasing atomic size, the valence electrons get shielded by the inner electrons, and so the energy required to remove them or it becomes less. Solubility. Solubility decreases with increasing size, which means it decreases as we go down the group. Lithium is the most soluble, while francium is the least soluble. Melting and boiling points. The melting and boiling points of group 1 elements decrease as we go down the group. So that's about enough of the physical properties of group 1 elements. Now let's look at the chemical properties real quick. Chemical properties. Oxides and water. The oxides of group 1 elements react with water to yield hydroxides. As we can see in this reaction, lithium oxide reacts with water to yield 2 molecules of lithium hydroxide. In the same way, sodium oxide will react with water to yield 2 molecules of sodium hydroxide. Next, carbonates and bicarbonates. The hydroxides of group 1 elements are alkaline. I guess that's why they're called alkali metals. Oh, that makes sense. And will react with carbon 4 oxide to form carbonate. In this reaction, 2 molecules of sodium hydroxide combines with carbon 4 oxide to form sodium carbonate and water. Nitrates. The nitrates of group 1 elements, except lithium, decompose to nitrites. In this reaction, 2 molecules of sodium trioxynitrate 5 will decompose to yield 2 molecules of sodium dioxynitrate 3 and oxygen gas. Halides. Alkali metals react vigorously with all the halogens, aka group 7 elements, to form solid ionic halides. Like in this reaction, sodium would react with chlorine to form sodium chloride, aka table salt. Lithium. Don't you just love the sound of that name? I like to think of him as the special child amongst group 1 elements. It has the following special or anomalous characteristics. 1. It is harder than the other alkali metals. 2. It reacts very slowly with oxygen gas and water, unlike the other alkali metals. 3. The hydroxide of lithium hydroxide, is less basic. 4. Lithium nitrate decomposes into nitrogen dioxide, oxygen, and lithium oxide, while the other nitrates of alkali metals yield nitrites and oxygen. And lastly, but certainly not least, lithium salts are less soluble compared to other alkali metal salts. Okay guys, so what are the important things for us to remember from this lecture? 1. What is the valency of group 1 elements? 2. What are periods and what are groups? 3. How many groups and periods do we have on the periodic table? 4. What are the trends in group 1 elements? 5. What is ionization energy? What is electronegativity? What are some chemical properties of group 1 elements? If you can remember all these, then you are more than good to go for group 1 elements. Okay guys, so stay safe, study hard, and I will see you on our next video.